Let's see the example of Thevenin and Norton theorems when the dependent source exists in the circuit. So as you can see in this circuit, there is a dependent voltage source, which is the value is 2ix, and then ix is currents that flow through the 2 ohm resistor. So the question will be, what is the voltage here? Vx, for example. So for the first step, remove the RL. So RL is 2 ohm. So remove the RL. Okay, and then the circuit will look like this one. You have to draw the circuit. I open circuit here. So this is a terminal A and B. Here is 2 ohms. 2 ohm, 10 volts. Here is 2 ix. So step number 2. Finds V Thevenin. Okay, when you redraw the circuits, and then you need to find the V Thevenins at terminal A, B. Here is V Thevenins. And then you need to find the V Thevenins across the terminal AB. So here is the circuit. You can see that there is one loop. We call that as I1. Okay. There is no currents that flowing through this loop, because you can see that here is open circuit, so there is no current that flow through this loop. We're only considering the first loop, and then apply the KVL at the first loop, at loop I1 minus 10 plus 2 I1 plus 2 I1 is equal to 0. And then you get the answer for I1 is 10/4, which is 2.5 amp. So actually I1 is Ix. Okay. Take a look at the second loop. So we need to find the voltage at V Thevenin. What you can do here is do the KVL. This KVL is for finding the voltage. There is a difference in between the KVL for finding the currents and KVL for finding the voltage. KVL for finding the current, it must be, there is all the element must be connected. It look like this one. This is KVL for findings I. Okay, you can see that all is connected. There is no open circuit in that circuit. But there is a difference in KVL for finding the voltage. So as long as you know the currents and resistor, therefore you can find the voltage for each of the elements, and then you can determine any locations of the voltage, and then in this circuit it can be open circuit. Okay, what you have to do is do the KVL at loops X. Okay, findings V. This one is for findings a currents. So now, what is the step? First is identify currents, directions. Marks polarity each element, and then do the KVL. Make sure that you already know the values of the currents. So now, here is the directions of currents for the 2 ohm. So we need to do the KVL here. X plus minus, that it will already have the plus minus here. Okay, I'll start with the Thevenins, which is plus Thevenin plus 2ix minus 2 times ix equal to 0. And then Thevenins is I need to do some correction, so here I choose 3 lah. So this means here is 3. Okay, so 3 ix plus minus 2 ix, so 3 minus 2 ix will be ix, which is the Thevenins is 2.5. Okay, this is the answer for the Thevenin. So I correct this also. Okay, now we need to do the I Norton. So you need to find the I Nortons here. So step number 3 will be find I Nortons that flow through from A to B. So IN is here. IN. As you can see here, there is 2 loops, which is loop 1 and loop 2. So I want to solve it using the mesh. So KVL at I1 minus 10 plus 2 I1 plus 2 I1 minus I2 equal to 0. 2 I1 plus 2 I1 minus 2 I2 equal to 10. 4 I1 minus 2 I2 equal to 10. Then KVL at I2. 2 I2 minus I1, and then plus with 3 Ix, then equal to 0. And then you have to separate the I and then groups the I. Minus 2 I1 plus 2 I2 plus 3 Ix, and then it will be equal to 0, and it will become equation number 2. And then the constraint will be, the equation will be, what is Ix? So Ix is I1 minus I2. We arrange these equations. Ix equal to 0. Substitute the equation to the metric forms. 4 minus 2 minus 2, 2. So Ix will be 0. So here is 3, 1, minus 1, minus 1. So I1, I2, and then Ix 2, 10, 0, and 0. Okay. And then solve it using calculator. Therefore, the I1 is 5 M. I2 is 5 M. Ix is 0. In is equal to I2, so equal to 5 M. And then step number 4, we already determines the values of Thevenin, which is 2.5 volt, and then I Norton, which is 5 M. Therefore, R Thevenin's equal to R Norton's is equal to V Thevenin's over R Thevenin. So it means that 2.5 over 5 equal to 0.5 ohm. Then you need to draw the Thevenin's equivalent circuit. R Thevenin is equal to 0.5 ohm. V Thevenin is 2.5 volt. This is terminal A and B. Then you should insert the load into the Thevenin equivalent circuit, which is 2 ohm, and then you need to find the V at the 2 ohm. You can use any methods. Either you want to find the I first, and then V 2 ohm is equal to I that flow through the circuits times with 2, or you can use the voltage divider. So I choose voltage divider. 2 over 2 plus 0.5 times with 2.5 volt is equal to, so equal to 2 volt. And then if the questions ask you on findings the Pmax, so equal to V Thevenin square for 4 R Thevenins. You have to write down this equation, which is RL is equal to R Thevenin, which is equal to 0.5 ohm. Substitute into the Pmax equation, which is 2.5 square for 0.5, then should be equal to 3.125 watt. So this is the finest values of the Pmax. So this is the solutions of the circuit with the dependent source.